Hello everyone, welcome to the video on alkyl halides nucleophilic substitution part. And this video is made according to NCERT class 12 unit 10 syllabus. In this video I am going to explain about solvolysis, ammonolysis, Williamson ether synthesis, Finkelstein reaction, what are ambident nucleophiles, ester formation, hydride reduction and carbon nucleophiles. Remember, all these things are given in NCERT textbook, but I am explaining in a detailed manner. They have given a chart with all the example of nucleophilic substitution reaction. I'll go into the details. This is my YouTube channel. Just type in my name G. Sarajesh, you will get the details. I have already made 2 videos related to alkyl halides. Let's get into the topic. Now, nucleophilic substitution is the characteristic reaction of alkyl halides. That means alkyl halides most frequently undergo nucleophilic substitution reaction. So what do you mean by nucleophilic substitution? See, alkyl halide is attacked by a nucleophile and halogen atom is substituted or replaced with a nucleophile. Because it is substituted, it is called as substitution. A nucleophile is substituted, hence it is called as nucleophilic substitution. Usually it is written as NS, nucleophilic substitution. Now let us understand what are the things required for this. See, there are 3 components necessary in any substitution reaction. You need to have an alkyl halide, but remember this has to be sp3 hybridized carbon. So sp3 hybridized carbon most frequently undergoes nucleophilic substitution reaction. What else you need? You need a nucleophile. Now, when the reaction is done, halide comes out as a leaving group because it is leaving from the substrate or leaving from the starting material. It is called as leaving group. Let us see individually about these components. Now, let us understand what you mean by nucleophiles is. See, nucleophile is made up of 2 words, phile and nucleus. Let us understand this one. What is a nucleus? What do you have in nucleus? Inside the nucleus you have protons and neutrons are there. Neutron has got a neutral charge, whereas proton has got a positive charge. So when you talk about nucleus, according to the charge, it has got a positive charge. Now phile means loving. So when you say nucleophile, you are talking about nucleus loving species. According to the general physics, opposite charges will get attracted. So what gets attracted to positive charge? A negative charge will get attracted, or a negative charge will love this nucleus because it has got a positive charge. So typically nucleophiles has got a negative charge or a non-bonding electron pair. So non-bonding electron pair has got negative charge because of its electrons. So nucleophiles are denoted as Nu. Some of them has got electron pair or some of them has got a negative charge, like these things. Look at them. It might have this negative charge or it has got this electron pair. So understand this, nucleophiles provide electrons for making of a new bond. So these species are called as nucleophiles. Again, you have 2 different kinds of nucleophiles are there. Not bulky, small sized, negatively charged ions. Like say oxygen carries a negative charge here, carbon carries a negative charge, cyanides or halides, bromides, or molecules with neutral atoms. See, all these are neutral atoms, but they do carry an electron pair, lone pair of electrons are there. So these lone pair of electrons will act as a nucleophiles. Now after that, let us understand about a leaving group. What do you mean by this leaving group? Look at this. See, when a nucleophile attacks this alkyl halide, this halogen is replaced and it is called as a leaving group. Now this halogen takes away these electrons along with it, so it carries a negative charge. Now understand these things. See, nucleophile also has got a negative charge, as well as the leaving group also has got a negative charge. So why it is leaving? Because it is a weaker base. Understand the topic, understand the term. See, comparing these 2, nucleophile and this leaving group, both of them you can see has got an electron pair. So see, leaving group has got an electron pair, so it can also act as a nucleophile, but it is a weak nucleophile. It is a very weak base. Now understand this, what do you mean by weak base? So weak base has got a pair of electrons. See, according to Lewis theory, electron pair donor is a base, right? Now weak base means it is not ready to donate these electrons and the charge is stabilized over here. So when it is stable, it will not go and attack this alkyl group as a nucleophile. Whereas nucleophile is a kind of strong base. It has got an electron pair, it goes and attacks this alkyl group. So understand the difference. Weaker bases acts as a good leaving group because they come out with electron pair but they stay as such. Whereas stronger bases acts as a nucleophiles. Now look at them. Among the alkyl halide series, the starting materials are alkyl chloride, bromide and iodides. So these molecules will undergo nucleophilic substitutions. We are not talking about alkyl fluorides because alkyl fluorides undergo very least possibly nucleophilic substitution. Now from this alkyl chloride, the leaving group is chloride anion, bromide anion and iodide anions. Now when you see among them, see chloride has got negative charge like this. Bromide, the size increases like this. Iodide, the size increases and negative charge will be like this. Now, when you see the stability increases while coming down. That means iodide is more stable than bromide is more stable than chloride. Why is this happening is this negative charge is spread over this big atom and the charge is stabilized. When the charge is stabilized, it acts as a very good leaving group. Otherwise, it is a weak base. So when it is a weak base, it is a good leaving group. So when you see the series of these alkyl halides, the most reactive one is alkyl iodide. Why? Because it has got iodide, which is a very good leaving group, and it immediately undergoes nucleophilic substitution. So understand this pattern. Now moving further, see this is what given in NCERT textbook. See in NCERT textbook, the nucleophilic substitution reactions of alkyl halide is given in a chart. We'll see each and every reaction in detail. Now what are the things given, what all the reagents are there, what is the nucleophile, what is the product, the substitution product and what it is called. Now the starting two ones, formation of alcohols, let us see them. Now see, these reactions are called as hydrolysis or solvolysis. Let us understand first what happens in the reaction and then we'll see the terms. See, alkyl halide reacts with either aqueous potassium hydroxide or aqueous sodium hydroxide or silver oxide. When it is boiled together with alkyl halide, it results in alcohol. What has happened? This halide is substituted with hydroxy group. Now, to perform this reaction, the solvent is taken as aqueous bases, potassium hydroxide, sodium hydroxide or silver hydroxide. Now the solvent is causing breakdown of this bond. Breaking the bond is known as lysis. How it has happened? With the help of solvent. Hence it is known as solvolysis. Solvent is causing the lysis or breakdown of the bond, hence it is called as solvolysis. When the solvent is water, it is called as hydrolysis. Hydra means water, lysis means breakdown. Now, water can also convert alkyl halide into alcohol. Only this happens with tertiary alkyl halides. When the alkyl group is tertiary, the reaction happens only with water when it is boiled. We'll see in the next class why this mechanistic approach is there, why only tertiary alkyl halides are doing this. But for now, understand what do you mean by hydrolysis, what do you mean by solvolysis. When solvent causes the breakdown of this bond, it is solvolysis. When water, hydra, is causing this breakdown, it is called as hydrolysis. Now, next important aspect is the reaction is irreversible. It goes in only one direction. But see, this is important. Why? Because alkyl halides can also be prepared from alcohols. So is there any chance that alcohol is converting back to alkyl halide? Because you have this halogen is there. It is not possible. It goes only in one direction. The reason is, see, OH is poor leaving group. See, just now we have seen from this OH will not come out as such. It is a poor leaving group, so it stays as such. The next one, see, halide is a weak nucleophile. The halide is stabilized one here. It will not go and again attack this alkyl group. So the reverse reaction is not possible. It is only forward reaction. So this is what is about hydrolysis and solvolysis. Understand these terms and reaction. Now the next one is Hofmann ammonolysis reaction. See, just now we have seen about solvolysis and this one is ammonolysis. That means ammonia is causing breakdown of the bond, hence it is known as ammonolysis. It is upon the name of Hofmann, hence it is called as Hofmann ammonolysis reaction. So what happens is typically an alkyl halide, when it is reacted with ammonia, the amine has got lone pair of electrons, so halide is substituted and you get primary amine. Now, when excess alkyl halide is used, the primary amine again attacks alkyl halide, and again you get a secondary amines. Now again one more hydrogen is there which can be substituted with alkyl group, hence the excess alkyl halide reacts and you get tertiary amine group. Now even after substitution of all these hydrogens, the nitrogen has got lone pair of electrons. So because of this lone pair of electrons, again it can form quaternary amine compounds. So look at them. This reaction results in a combination of primary, secondary, tertiary and quaternary amine compounds. And all of them will result in the breakdown of this alkyl halide bond. Hence it is known as ammonolysis. This is not a good method of preparing amines because it gives a mixture of primary, secondary, tertiary and quaternary compounds. But understand the reaction. This is what is known as Hofmann ammonolysis reaction. Again, it is a typical example for nucleophilic substitution. What is substituted? This alkyl halide is substituted with amine group. Now coming to the next one, Williamson ether synthesis. See, as the name says, it is a named reaction for the synthesizing ethers. How it is synthesized? Alkyl halide, when it is reacted with alkoxide ion like sodium ethoxide, the alkoxy group replaces this halide group and forms ether. A simple reaction like bromoethane, when it is reacted with sodium ethoxide, results in ethoxy ethane. A very good method to synthesize ethers. Again, this is an example of nucleophilic substitution. What is nucleophile here? Alkoxide ion. What is substituted? A halide. Hence it is known as nucleophilic substitution. Now Finkelstein reaction, this one I have explained already in my previous video. This is the best method to synthesize alkyl iodides. What happens? This is also known as halogen exchange reaction. Look at the reaction. What is happening? One halide is converted to another halide. Hence it is known as halogen exchange reaction. But why is this reaction happening? It is because of the solvent dry acetone. See what happens? In dry acetone, sodium iodide is soluble. So the reaction occurs and it forms ethyl iodide and sodium chloride or sodium bromide. Now sodium chloride and sodium bromide, both of them are insoluble in acetone and they forms precipitates. These precipitates are taken out and the reaction moves forward and reaction forms only alkyl iodides. Because of this, this is called as differential solubility. Differential solubility means only sodium iodide is soluble but not sodium chloride and sodium bromide. So the reaction is pushed to the forward direction according to Le Chatelier principle, and it is a very good method to synthesize alkyl iodide. Again, this is a nucleophilic substitution. What is the nucleophile here? Iodide. What is getting substituted? Chlorides or bromides. So this is known as Finkelstein reaction. Now moving further, now this is an important topic. It is known as ambident nucleophiles. Now understand this one. Ambident means a nucleophile, anionic nucleophile, which has two nucleophilic centers or two negative sites. Look at the cyanide ions. Now cyanide ions, the negative charge can be on carbon or can be on nitrogen. So you have two reaction centers. It can react with either carbon or with nitrogen. Similarly, nitrates. Nitrate also you have two, the negative charge is delocalized on two oxygen atoms. So this is because of resonance. Now let us see the reactions. Now see, when alkyl halides, when they are reacted with potassium cyanide, they results in alkyl cyanides. When cyanide group carbon is attached with alkyl group, it is known as cyanide. Whereas silver cyanides, in presence of alcohol, when they react, they form isocyanide. Understand this functional group. When alkyl group is attached with nitrogen, it is called as isocyanide. So these are cyanides, these are isocyanides. Why is this happening? Why potassium cyanide is forming cyanides whereas silver cyanide is forming isocyanide? Let us understand the reason. Now look at them. See, potassium cyanide KCN is predominantly ionic. Ionic means it is ionized as K plus and Cn minus. So what has happened? The negative charge is present on carbon. So the moment negative charge is present on carbon, it acts as a very good nucleophile and it attacks alkyl group and forms the bond as alkyl cyanide. See, carbon and nitrogen both can donate electrons because nitrogen has got electron pair, but the bond formation of carbon to carbon is favored than carbon to nitrogen. Look at them. See, this carbon, this is carbon to carbon bond. But when nitrogen attacks, it forms nitrogen to R, that means nitrogen to carbon bond. Now this is weaker than carbon to carbon bond. So because the strength of carbon to carbon bond is more and the electron availability is there on carbon, the bond formation occurs through carbon and they form alkyl cyanides. So this is what happens. Now what is happening with silver cyanide? Now silver cyanide is predominantly covalent. Covalent means the availability of electrons and the carbon will be low. So they are just pulled towards carbon, but unlike ionic, electron pair is not available on carbon. So where do you have electron pair? On nitrogen. So the bond occurs from this nitrogen. Alkyl halide will get attacked from the nitrogen because electrons are present there. So what happens? The bond formed here is nitrogen to alkyl group. And these are known as alkyl isocyanides. So this is what is the reason. So it depends upon whether you have an ionic compound or covalent one. Ionic one, the charge is directly present on carbon, so it attacks. Whereas in covalent, electrons are displaced towards carbon, but ready availability is there with nitrogen lone pair electrons. Now similar things happens with nitrates. So again, potassium nitrate, what happens is again potassium, it is predominantly ionic. So oxygen has got a negative charge. So the negatively charged oxygen will attack this alkyl group and you have alkyl nitrite is there. Understand this one. When alkyl group is attached with this oxygen, it is known as nitrite. This is with potassium nitrite. If you use silver nitrate, now see, silver nitrate is covalent. Both oxygen nitrogen atoms have lone pair of electrons. Now what happens is, see, electrons are present on oxygen as well as nitrogen. But when you compare oxygen and nitrogen, oxygen is more electronegative. More electronegative means it will withhold the electrons with itself. So when there is a competition between these two, nitrogen can easily donate electrons than oxygen. And all this is happening because the bond is covalent. So ready availability of electron pair on nitrogen makes the bond with alkyl group and you get nitroalkanes. Again, when alkyl group is attached with oxygen, it becomes, say in case of potassium, it makes nitrite. Whereas when alkyl group is attached with nitrogen, it is nitro compounds. So silver one forms nitro compounds, potassium one forms nitrite. So because both the atoms can attack, they are known as ambident nucleophiles. Now the next one, ester formation. See, silver salt of carboxylic acid can be converted to an ester when treated with alkyl halide. So this is one of the method of making esters. Now another important one, reduction with lithium aluminum hydride. Now understand this one. A hydrogen has when you see the hydrogen nucleus, it has a proton and one electron revolving along this nucleus. Now when this electron is knocked out, hydrogen is converted to proton. We call it as proton because when you remove this electron, it has got nucleus only with a proton, hence it is called as a proton. Now what if it gains one more electron? If it gains one more electron, it is called as hydride. Understand the differences. This one is proton, this one is hydride. Now this is lithium aluminum hydride. Because aluminum, all these are metals which are readily donate electrons, it results in the formation of a hydride. This hydride is nothing but hydrogen nucleophile. It has got ready availability of electron pair. This hydrogen nucleophile will attack carbon and substitutes this halide. This is called as reduction with lithium aluminum hydride, and it results in the formation of alkanes. Because a hydride is substituted, it is also known as reduction. So lithium aluminum hydride is a very strong reducing agent, and the reaction takes place in presence of ether. Now the next one, Wurtz reaction. Now understand this one. Alkyl halides react with metallic sodium in presence of dry ether to give symmetric alkanes. Now this is what is the reaction. Two of the alkyl halides in presence of sodium metal with dry ether results in the formation of symmetric alkanes. Means you can see two of the alkanes are getting attached and hence they form symmetric, equal number. Like if two of the methyl groups are combining, it forms this one. If ethyl groups are combining, they form 4-membered carbon. Now technically what is happening is, let me explain this. Now see, this forms a metal alkyl metal. Now metals can easily donate electrons, so it results in the formation of carbon nucleophile or C nucleophile, and this C nucleophile attacks alkyl halide, results in the formation of a bond between carbon and carbon. and that results in the formation of these symmetric alkanes. See, both lithium aluminum hydride and Wurtz reaction, both of them will form alkanes, but the difference is Wurtz reaction, same number of carbons are there, only a hydride is substituted, whereas Wurtz reaction, the number of carbons are doubled. So this is what is Wurtz reaction. This is also typical substitution reaction wherein this carbon nucleophile replaces halogen and you get an alkane. So these are all the typical nucleophilic substitution of alkyl halides. So in the next class I will explain about SN1 and SN2. If you like the video content, do subscribe and share. Thank you for watching this video.